All right, when we finished the last video, we were here. We just constructed our scatter plot and decided that we had a linear, positive, and strong relationship between knee height and the overall height of a person. So the next step in our data analysis is to calculate numerical summary. The name of the numerical summary that describes the strength of the linear relationship between x and y is called correlation. And you never have to calculate correlation by hand in this class, thank heavens. It's really not that fun. So I had Minitab go ahead and calculate the correlation between height and knee height for us, and it came up with 0.89. So you remember that correlation can be any value between -1 and +1. And the closer you are to -1 or the closer you are to +1, then the stronger that relationship. So this value, 0.89, is pretty close to +1, which would indicate a strong, fairly strong positive relationship between those two variables. So second step is calculate numerical summaries. We've done that. The third step is to model the data. So in this case, we're looking at a linear relationship here. So the best way to model that is through a least squares regression line. So here's the formulas from your book on calculating the values for the least squares regression line. So we're just going to use these formulas to help us come up with the intercept and slope so that we can create that least squares regression equation. So you'll notice that this just uses the means and standard deviations for both x and y, and it uses the value of r, of the correlation. And if I were to ask you to do this on an exam, I would provide all of these values for you. So I would never expect you to calculate standard deviation again by hand. That was just saved for the first test. Definitely never calculate correlation by hand, and means aren't too hard to find, but I would give them to you on this exam. All right, so let's look at what we have here. So we want to start with calculating the slope. So slope, or b, is equal to r times standard deviation of y divided by standard deviation of x. So if I just plug in all those values that I have 0.89 times standard deviation of y. Y was our height, and maybe it'll even help if I draw the x and y over there just to remind ourselves of what's what. So standard deviation of y is 16.62, and standard deviation of x is 6.03. So if I multiply all this out, I end up with a slope of 2.453 if I'm carrying out 3 decimal places. Next, I can find my intercept, a, by taking y bar minus b times x bar. And all these formulas are coming from this little spot in the book right here, which is going to be on your exam. So again, I'm just going to plug in the values here. Y bar is the mean of the y variable, so it's that 166.9, minus b, which we just calculated over here to be 2.453, times x bar, mean of the x's, which is 50.53. So if I do all of those calculations, I end up with 42.95. So that's going to be my intercept. So I could go ahead and write out the formula for the least squares regression line. I'm going to have y hat is equal to 42.95 plus 2.45, if I rounded 2 decimal places, times x. So this is the equation for the least squares regression line for predicting overall height from knee height. So let's talk just for a minute about the different terms in this model. So let's start with this 42.95. That's our y-intercept. So basically what that says is that if there was someone who had a knee height of 0, we would expect their overall height to be 42.95. So really this isn't very realistic. Wow. I think my neighbor is having their yard done, so I apologize for the background noise, and hopefully you can still hear me. Obviously that's kind of silly. We're not going to find a person who has, that has full function of their limbs that's 0 centimeters for their knee height. So this number is really more of a placeholder in our equation rather than something that we actually interpret. The really, really interesting part of our model is the slope, which is this 2.45. And what makes the slope the coolest part of our model is that it really quantifies that relationship between x and y. So in this case, it's saying that for every 1 centimeter increase in knee height, so for every 1 centimeter increase in knee height, we expect the overall height to go up by 2.45 centimeters. So for every 1 centimeter increase in knee height, we expect height, the overall height, to increase by 2.45 centimeters.